Hey Levins, I'm back with a new video here. This is for our second lesson. Hopefully you're watching this tonight, Thursday night. Factorising. Hopefully you've done some of this before. Some of you won't have done some of this before, things like quadratics, right? Maybe grouping in pairs or something might be a bit unfamiliar as well. I might make some supplementary videos to go through those. They might be sorts of things you need to see a bit more of. But let's jump straight into some examples here and we'll see how we go. First thing you should be looking for when you have to factorise an expression is a highest common factor, right? Something that will divide each one of those terms. So here I could divide either of those terms, right? Either of those would be divisible by x squared. Right? If I were to divide 4x cubed by x squared, I would end up with 4x. And if I were to divide 3x squared by x squared, I would get 3. If I expand that expression again, I get back to 4x cubed plus 3x squared. That's good confirmation that what I've done is correct. It doesn't tell me that it's complete. It does tell me it's correct. Okay. Next up here. Highest common factor of these two terms, right? I've got two terms separated by a plus or a minus. 6 is common to 18 and 30. There's no common a. There is a common b cubed. So 6b cubed is my highest common factor. That would leave me with 3a squared minus 5. Yep. Right. Highest common factor. Don't forget to do that. You won't get too many questions that are just factorised by taking out the highest common factor. But you will get ones that certainly makes life easier. Sometimes when you're stuck with what seems to be a really difficult problem, do that first and what's left might be easier. Sometimes that's the first step to a more complicated question. Difference of squares. Now, you need to recognise this. You need to become familiar with it when you get a square minus a square. For example, a squared is a square. 36 is a square. 36 is 6 squared. 6 times 6. So if I've got a square minus another square, then it can be factorised into the square root of this plus the square root of this, of the positive part. Multiplied, right? A plus b, a minus b. Righto. Difference of squares, so difference meaning subtract. If I see that, right, I've got to keep an eye out for it. If I see that, then it factorises like this. Right, so that means that would be the same as a plus 6 multiplied by a minus 6. Right, difference of two squares. You can see how that works out. If you expand that, you will end up with a squared minus 36. Now, 80x squared isn't a square, 5y squared isn't a square. They've got a common factor, right? First thing I'm going to do is take that common factor of 5 out of there. 5 out of 80. 5 out of 80 will give me 16, I think. I'm going to have 5 outside of 16x squared minus y squared. Right now, I have a difference of two squares there. So I get 5 outside of 4x plus y 4x minus y, right? That is factorising using the difference of squares. You've got to keep an eye out for those where you've got a square minus another square, possibly with a common factor. Now, monic quadratics. Right? Quadratic has a squared term in it. Right? Takes this form here. Monic meaning it's not 2x squared or 3x squared or 4x squared or negative x squared. It is an x squared. The coefficient of the squared term is 1. Right, there's some rules there. Read through those. Let's have a look and see how these are done. This is the sort of stuff that if you were in the middle classes last year, perhaps you won't have seen this before and it will be tricky. Right? We'll talk about that in class. For those that have seen this before, want a refresher? Right, let's have a look. I'm looking for two numbers that multiply to give me 36 and that either add or subtract to give me negative 13. Okay, now it's negative. They're both going to be negative numbers. They're both going to be negative because this is positive and this is negative. Check that on that little table before. Now, two different numbers, 13, 36, 4 and 9, I reckon. So we have x minus 4, x minus 9. Okay, factors of 36. 36 is a little bit tough because it has lots of factor pairs. but I'm looking for factor pairs that combine to give me negative 13, and minus 4 and minus 9 give me those. 6 and 6? No. What else could we have? We could have 18 and 2 multiplied to give me 36. No, they don't get me to negative 13. Negative 4 and negative 9. All right, check by expanding that. There we go. Let's have a look at the next one here. Well, this is a negative, so I've got a positive and a negative factor. Right? Positive and a negative multiplied to give me a negative. So I have a positive and a negative number. They have a difference of 12. Now, what sort of numbers get me to 28? Well, difference of 12, I think it's 14 and 2. So I think it's plus 14 minus 2. So A plus 14, A minus 2. I would expect you to have to probably sit and think about those for a little bit longer and maybe test a couple of things. Okay, I'm going through them fairly fast. Our video is getting long, but factorising these things, practice definitely makes you faster. Right, there are some other ways of doing these that we'll learn later on, but you need to be able to do this. You'll need to practice these quite a lot. Right? More stuff for class, but you've got some examples. There are some to do. Now, grouping in pairs. Right, this is going to be this is the next thing that we want to look at. Grouping in pairs is where we get probably 4 or more terms, and I don't have a common factor to all of them. Right, it's not a quadratic. Sometimes, and not always, sometimes you can factorise parts of that expression, and what's left becomes a common factor as well. I'll show you how that works. Let's look at these first two terms, 12xy and 9x. Well, I could take a common factor of 3x out of these two terms. Right? If I took 3x from those, I would end up with 4y minus 3. Okay, so if I expand that part, I'll get these two terms here. Now I've got minus 16y plus 12. Common factor there? Well, you know what? I think if I could divide both of those things. I reckon I could divide both of those by negative 4 if I wanted to. Right? So if I had minus 4 outside of, that would be 4y minus 3. Okay, if I expand this part here, I get minus 16y plus 12, which is this part here. So if I expand that, right, I get back to here. Now, I'm actually down to 2 terms, and they have a common factor, this thing here in brackets. So I can take that common factor of 4y minus 3. That belongs to both of the terms. Right, if I divide this term by 4y minus 3, I would just end up with 3x. If I divide this term here by 4y minus 3, what would I end up with? Negative 4. Okay, now you can confirm that that is a correct factorisation by expanding. If you do that, you're going to see that we get back to here. This is a bit interesting. This does not always work, but bit of a tip, if you see an expression with 4 terms and it says factorise, there's a good chance that you're being asked that question to use this method, that it works there. Check that. Now, this is much more interesting, example B, and I'm going to stop when we get to the bottom of this one here. Now, I've got 4 terms there. There's nothing common to all of them. It's worth checking that out. I've got a couple of squares. What's going on here? Quite a lot, actually. So let's have a look. This one here, can I factorise the first part? Well, that's a difference of 2 squares. So that is s plus t, s minus t. Right, factorise the first 2 terms. And then I've got, well, look, I'm going to do it like this, plus 1 outside of s minus t, just so that I'll factorise. You can always take a factor of 1 out. It's not usually very helpful, and I don't know that I always write it. It's going to help us here. Now you can see, though, that we've got a similar situation here. I've got 2 terms. Started with 4, now I'm down to 2 terms, and they have a common factor of s minus t. So let's put that common factor at the front, s minus t, and I'm left with s plus t, I like it, plus 1. And there you go, that's factorised. It's quite an interesting example, I think. If you expand that, you'll get back to s squared minus t squared plus s minus t. Right, but there we go, factorised. Non-monic quadratics, I'm going to leave that for next time. Okay, watch the video, pause, rewind. You might want to jump ahead and have a look at the next exercise. It's exercise 1C. You can have a look at 1B if you like. That's the expanding stuff if you want a reminder of how to do that. Righto, enjoy. I'll see you in class.